Welcome back to round 2 of our workshop. We will see what problems we can face this time. Last time we started a project in R, and now we are at the point where we have an R chunk involved. What the possibilities are endless now. What we're going to be doing is loading in our data set, and I shared that with everyone previously in the chat, and and if you're viewing this later on, we'll have a link to be able to download the same data file here. What you're going to want to do now is I'm in our regular pane, just like looking at the project in your Windows Explorer or however you're navigating to this. And what I like to do is create a folder in here. And this is, again, just for how I like to organize things. This doesn't mean that this is how you have to as well, but it would be a nice way to start a new project. I have a folder just dedicated to data. And this is where what I will do is actually put in the data file that we just created, and I am going to navigate to that right now. I have it in my downloads folder, and all I'm going to do is I'm going to Control C, just copy and paste it. I'm double clicking into our data folder, pasting it right in there. So now we have our physical, our like raw data in our project. And if we go back here to our R Studio, you can see now in the bottom right in our Files tab, we now have a data folder. And if you were to click on that, there is your CSV file. That's the same CSV file that I have. I hope somehow it didn't change in transit. But it's showing you where everything lives. So I just clicked back again right here. You can see is the basically file path to get to where we want. And I usually just situate it within the regular. It doesn't really matter where it's looking. That's more for navigation than anything else. So now we need to load in our data. And the way to do that, we are going to start with our code chunk right at the beginning. Anything in between these, there are 3 backticks and then a squiggly bracket, the letter R, squiggly bracket. That is going to let our Studio know that there are that is the type of code that wants to be run, that language. And that's what it defaults to, using R. So anything between these 2 backticks is going to be R code. Sometimes what's happened to me is I accidentally will either delete 1 or 2 of those backticks or all of them. And that means that then your R code just goes on forever. And it will make it difficult to run code, or anything that's after it will then be turned into R code. And you don't want that. So sometimes if you're running into problems, that might have happened, and you can just put those 3 backticks back. And the backticks are in the top left of the keyboard underneath the escape key. It should be right there. So let's take a look at, let's see. I'm just going to open the CSV data file. And again, this is just like, you might be, used to seeing this format if you've worked in Excel before. CSV just stands for comma separated values, and it is a very just raw and straightforward way to save and manage data. Excel is able to open these, but really all it is each cell is separated by a comma. And you can also open this in a text editor. So you don't have to do this. I'm just showing this this is actually what it looks like. And then when Excel reads it in, it's like, hey, I know that at each comma I need to put a new cell. So sometimes you might have saved a CSV and then tried to open it in Excel, and then it spits out this and that. Then you're like, oh no, what did I do? But that's how the data is supposed to be. It's very easy to read that in. If you are using Excel documents as like .xlsx or .xls, that will require additional information to read in the data file. And I can show how to do that. Using CSV is usually the most common, and that means that there's only a single sheet of data. If you do have multiple sheets, then you'll have to take additional steps or use a different package or library to say, hey, I want to load in sheet number 2 or sheet with this name to it. And I'll walk us through how to find that information. But right now we just have a simple CSV file that lives in our data set. So here in our code chunk, what I'm going to do is we want to name the data. And this is just a name. Sometimes you can load in multiple data sets, and we'll probably be doing that tomorrow during the next workshop. So usually you name your data something that makes a lot of sense. And this, I believe, was the tuition data set. Whenever you name an object, which is what we're doing here, you don't want to use spaces. And capitalization matters and is very important. Punctuation is also important. So I usually try to just keep things simple and straightforward, because if you want to refer to this data set again, you have to type that whole name out, and it can get, if it's too long, you get angry with yourself. Now what we want to do is we want to assign this object with something. And the way to do that is to use a left pointing arrow and a dash. So this is saying, I want to take what's on the right side of this arrow, and I want to assign it and put it into this tuition variable. This is where I often use a keyboard shortcut. And this on mine, I have it set to be Alt dash. So just Alt dash, and that will give me a nice arrow that I can just arrows all day. Why did I do that? I don't know. So you can set that to something. I can't recall what the default is, but you will be using a lot of the arrow assigner operator, and having a keyboard shortcut for that is awesome. So we want the tuition. We want to create a variable named tuition that houses our data set. The spaces after or before things do not matter. However, it makes your code look a lot cleaner and easier to read. So I would suggest getting into the habit of including spaces where I am as well. Now what we want to do is we want to read the data. And that's usually how you read in data. You tell R how to read data, and you go from there. So to read in a CSV file, this is something that is automatically in R, and you don't need to install anything extra. And you can see as we type read, it comes up with lots of different things. And you can see that there's a lot of different things that R can read. But the most common and the one that I use the most is CSV. And here, now what you're going to want to tell it is, where is that data? Where does it live? And because we have set up this project, our home base is, if we look down here, our home base is where this project starts. So that is home, basically. This is where everything starts. You don't need to say C:\\/ your name and like all those things, because that, if I were to try to run that on my machine, it wouldn't work. Or if you tried to like send it to a computer you were using at school, that's not going to work. And that's another point where the R project comes in real handy, because all we have to do is say, we know that we put our data file in the data folder. So we need to tell it where it is. And because sometimes our file names can have spaces or things like that, we read it as what's called a string variable, which you don't need to think too much about that. you just need to put it in quotes. So it can be double quote or it can be single quote. That does not matter. I usually use single quote just because it's easier. I don't have to push the shift key then, which is so time consuming. So we're going to say data because it's in this data folder. We are going to do, I always forget if it's forward or backslash. So we'll give it a shot, see if maybe it's /. And then we need to say, what is that data called? And I am very unoriginal and called it data. It's very confusing. And then we need to say what kind of file it is. And now we have this. And you typed it, you're like, good, I'm done. We're not. We need to run it now. And you can use your keyboard shortcut. For me, I'm going to use Control-Enter. You can see down here in our console, it runs. And then up in the right, we get our tuition data set. That it's sitting right there. It's hanging out. And you're like, I wanna see it. So you can either go down here and type view, and then you want to say you're calling on tuition. You can see as I start typing, it suggests like, hey, I think you want to look at this. And again, that's, you'll start getting used to how quickly that works. And then you can take a look at it. You're like, oh my gosh, that is our data. I'm going to take a pause here, see if anybody has any questions. If not, we're going to celebrate you reading in your data set. Kate just celebrated. Too early, Kate. We need to see if they have problems.
All right, too soon.
And again, like however many spaces are in between or up above, I usually like to have some space. It just looks better in my eyes. So that's why I enter. You don't need to. Again, like you can still have no spaces here and that will still run exactly the same. It's still going to do the same thing. I just like the spaces make it more readable. And I know where is it going? What's the name? What's the operator? And then what is this function? We have nobody having any issues. People are probably on YouTube watching this later and like, oh no, I have so many questions. Too bad, future people.
All right.
Yeah.
Oh, sorry, just checking to make sure we're all good. And no shame in taking a while to have your data read in. Again, on my final assignment of the year, in which I had spent so many weeks learning R and R code, it took me like 25 minutes to load in my data. And I was like, have I learned nothing? It just takes a while sometimes.
It does. And it's one of those things that just as you practice it and as you, like at the beginning, you need to give yourself that time to then like, oh, what's not working? And oftentimes it might be sometimes like a little sneaky space gets in the name of the file. And you just need to be careful about those, looking for that. Or if it's like the quotes or forward or backslash, let's see what happens if I put a backslash. See, it's like, I don't know what that is. What are you doing? So then you just listen and say, all right, I need to do /. And I think there's something, I don't know if it might just be in the way that the files are for Windows versus Mac. And I think that might be a slight difference, but I'm not sure. All right. I hope you all are celebrating and like just popping champagne at this early in the day or whenever it is. I don't know when you're watching this, and just excited because that is often, like I said, that's often one of the hardest parts in getting that. And I know it's one line of code, but it's a lot. And one of the things that I want to bring us to, so I'm going back to Firefox here, just searching the one, not Rudolph the Red-Nosed Reindeer, rdocumentation.org. This is a really useful tool to use in reading in the data. or just like not in just reading in the data, this is where I often go to look for how to problem solve things, or what do certain packages do. And if we go here and just type in read.csv, you can see that it has lots of different things. It's actually part of this larger read.table call. And you can see that it has all of the information about each of these, with each of the different steps here. You put in what the file name is. You want to see, are there headers? Are there other things? And you can, if your data is complex from a CSV standpoint, then you can update and change those. The one that I wanted to just point to is going into looking at read.xlsx. This is a separate package that needs to be downloaded. There is a couple different ones. The one that I've used in the past is called Open Xlsx, and you can see up here, this is the name of the actual function, where up here Open Xlsx is the library that it comes from. So it's saying this is from this section here. And this would be if you have an Excel file that has multiple tabs that you aren't able to export into a CSV. I will usually we'll need to, if I can't export to CSV for some reason, then you use this. And instead of saying read.csv, you'll say read.xlsx, and then put in the name of the file and what sheet you want to pull in. So in order to...
Oh, sorry.
Yeah.
When you have a break next, we have a problem that we need to troubleshoot quick.
Cool. So one way to... This is jumping ahead just a little bit, but usually what I like to do even before I load in the data is to have another code chunk beforehand. So we'll be doing this in just a minute. You can do it now, or you can do it when we're doing it in, like I said, just a little bit. So you can insert a code chunk here, and this is where I would actually include all of my libraries. Again, remember, you have the book, but you need to tell RStudio that you want to use that library. And here, if we want to use that Open Xlsx, then you would have to have that there and have it run beforehand. But right now we don't need that, so I'm going to delete it just for right now. We'll get back to it. And this is all we need in order to read in our data set.
So just to jump in here with a quick question that you're a good person to answer it. Why do you choose this method with the code instead of file import data set?
Yes, that is a really great question. And it is, so you can do that. There is a shortcut here into import data set. You can read it in from anything. The reason why, and so here I will just do that very quickly. See, I don't usually do that, so I'm not going to. But it is very easy where you can just you can grab the file path, you can browse for it and find it. What it is going to do is exactly what we just did, but we are being explicit about it. You can read it in like that. Just be sure that you are copying this code down here and putting it in your document itself. Because if you don't load in the data at the beginning, you're not going to have data to work with. And it is really important that this is explicitly done, because if you are sharing it with somebody, or for some reason your computer crashed or you moved the file, then it's going to take those extra steps to load in the file again. But since we have this project again, so I'm just going to go back. Here's our folder. I can copy this folder and I can send it to anybody, and they can do the exact same thing and get to the same exact part that I'm at. And that's what makes this really unique and really easy. And it's like very easy for you to, as your future self, to look back and do this very how are we doing. I see another question that we do have an extra variable. There is an X variable. Oh no. This is an artifact from when I wrote the CSV file. So you may remember when we originally imported it, there are 10 variables. It starts with name. However, when you write a CSV using that write.csv function, it will include a column that has row numbers. This is it's a default piece that you can override if you want to. In this case, I didn't, because now we can find out how to take away columns, which is useful. It can be useful, but again, the data is here. We can do with it what we need to. It doesn't need to look nice, because we'll be able to work with what we want. And if we can go back to our R documentation on Firefox, and if we just search for write.csv, you can see, again, it's part of this write table. It's just a larger R core package. And you can see that these are all of the defaults. So it is going to say there is an option that says row names equals true. So if we wanted to write whatever data file we have to a CSV, so let's say we wanted to do this. We would say write.csv. We want to use the tuition. You don't have to do this. This again is just to show how the functions work. We want to say where we want to write it. So I'm going to say data data2.csv, and then here we would say comma row.names equals false in all caps. And so if I were to run this, it would not write another column function or another column like that. That's a really great question, one that I was getting confused on when I first was writing CSVs. It just like randomly puts that on there. It's more of something to that if you're merging data sets, just like it does it automatically. I'm not sure why. So we'll have almost 3,000 variables, 3,000 observations with 11 columns. And now what we want to do is, let's say, so here we'll take a look at it, look at the data. So here you can, if you haven't already, you can view it by either typing view capital V tuition, running that, or you can click on that, and then we can take a look at our tab. So this is one of the things that I think is really helpful is there may be times when you want to subset your data. And one of the ways to do that is right in the beginning. And like in SPSS, it might just be filtering based on certain things. And we can do that here in just a second. One of the ones that I think is really helpful is selecting columns. So let's take away this X column. And there are multiple ways to do this. One of the ways that I really like to do is use the tidyverse and like tools within that. It is a larger system which will also have resources to what the tidyverse is, for if you want to peruse those moving forward. So we want to, because the tidyverse and all of the information within it is a separate book, we have to first go and get the book. So what we're going to do, because you don't want to install it every single time, so you can just type this down in the console. So down in the console, we're going to be using a package called Dpplier. So here I'm going to say install.packages, open parenthesis, quote, and then Dplyr, Dpplier. At least that's how I say it. And I don't know how to spell. So install.packages, you should spell it correctly, and then you won't get an error message like I did. So Dpplier, and I already had it installed, but it will just go and do it again because it's like you told me to do this, so I'm going to go do it. Now we have it. We have the book. It's in our own personal computer, and now we need to tell our script, hey, let's go get that because I'm going to use it later on. I usually like to have my first chunk being all of the packages or all of the libraries that I'm going to use. And it can be very useful for someone just viewing your code first off to know, oh, that's all that they're using. It's helpful for you just to stay organized so that it's not like, oh, you get down in a script and you realize you didn't run a library. It's just everything is all in one spot. So now we can do library Dpplier. And when we run that, again, Control Enter, or we hit run, you were going to see that it is including this package Dpplier, and then we get some masking, which is okay. This is expected, given the fact that when someone writes new code, they're using very similar words. So there is in the package stats, there was a function called filter, or there's a function called filter, and there's a function called lag. And there are also functions in Dpplier that use those same terms. And R is like, I need to pick one of them to use when you say filter. And it is saying that it's going to default to whichever one you loaded last, meaning we just loaded the library Dpplier. So when you type filter, it's going to look to Dpplier. Okay. I think because I had already downloaded it. It's like it's not working for some reason, but I was able to load it and everything's working fine. So when I type in filter, it's going to automatically, I'm probably going to have to restart R in a second, but we'll get to that. It is going to automatically look to Dpplier for that. If you want to use the one that it is masking, you have to just say where you want to pull it from. But the masking is, usually there aren't lots of conflicts like that, so you should be okay moving forward, and I'll try to point things out that I've run into.
Have you ever run into an issue? Because I haven't in my basic background, but I've never run into an issue where I'm trying to use a library's function, and it's like, no, you can't use this because you're currently working with this library.
Sometimes it's happened. It's like very rare. It's usually when you're working with multiple libraries. And really one way that people say to get around that is to, whenever you're using a call or a function that has some conflict, you would always use the name of the library first. So let's say we wanted to use this filter option. What you would do is actually say, I want to use Dpplier, and then you say colon. I'm going to restart R in just a second. Colon. And then now it's saying, when you use those double colons, it's like only looking at Dpplier. And that's a way to then force it to do that. But I haven't really faced any difficulty there. So I'm going to save, and then I'm going to do session, restart R. Usually I just clear everything just to be just a nice way to do that. So now you see my my tuition environment, like that's gone, but that's okay. I can just hit this, and I can do then this one, and there it is. We're back up and running. No big deal. So now we have Dpplier, and you might be like, why are we doing this so far? It's going so slow. I promise. We got it. Kate, did you have, it looked like you had a question.
No, I'm okay. Just, yeah, you're good.
Perfect. We want to select particular options. So I know I had mentioned this at the beginning before we started recording, but in our studio, there are cheat sheets. And one of the ones that I often look at is this data transformation with Dpplier. And so if we navigate to that, and I am going to open it here next to this. It will open in your native browser. I just have it, so this is just a nice clean version. And this visualizes a lot of the components of Dpplier and the things that we're going to be working on. So you can look at all the cheat sheets through RStudio. They're wonderful. And what we are going to want to do, and you can have these up. You can save them. You don't have to keep opening them every time. We'll probably either try to include them in the blog post or at least link to them. What we want to do is over here in the right column, we are going to extract some variables. We only want to have any sort of, we only want those particular columns. So what we're going to do, I'm going to go back to, I'm going to minimize here. Again, this is under help and then under cheat sheets. And then you can see all of them, or you can go to browse and there will be lots of other ones as well. So what we want to do, we want to select certain ones. I am going to close, we're going to want to use this select function. I'm going to zoom in because we only want to have certain columns. So if we go back here, there is a select function. So if we say select, you can see that there's the Dpplier, and we want to select from a particular data set. We want to say we want to use the tuition data set. That's what we've named it. And then we need to tell it what is it that we want to select. And this is going to be the names of the columns. So one way to do that is you can view your data set again and look at all the names if you want. One more efficient way is to, down in your console, you can just type names, open parenthesis, and then the name of your data set, which in our case is tuition, and it lists all of the names. So let's say we just want to have the name. For some reason, maybe we're like, this makes a lot of sense. We just want all the names. So we're going to run that, and it's just going to give us, hey, here's all your names. And it puts it in our output right below the chunk. That's where we said we wanted it. This is, again, where it's going to table things out. So you have lots of these names. It has almost 3,000 columns, 3,000 rows. And this is the basic setup for how to select pieces. But oftentimes you don't just want to select one thing. You want multiple columns. And what you're going to want to do there is create a list. So you are concatenating. It's just like a concatenation, meaning a combination of a number of different names of the columns. And to do that, you use, I'm just going to type it down here so you can see what it looks like first. It's just C and then open parentheses. So I am in the second part here because we have our select, tuition, and then we need to tell it again, what are the ones that we want? And I'm going to use a list of them. So C concatenating, and you can either type all of them out, which again, I want to save you time. So don't do that. Please don't do that. You can actually just type name, colon, and then let's go all the way to in state total. In underscore state underscore total. And I think this should work. If not, we may need to put these in quotations. So all this is saying is take the column name, look for that, and then take everything from that until our in state total. And if we run that, oh, see, I just highlighted that one section and tried to run that, and it's like, I don't know what that is because I needed to just have my cursor in the line, and I'm hitting Control Enter. And you can see now that it's just spitting this information out down here. It's not super helpful to us. because we're just saying select these things. We're not telling it where to go. We're not telling it what to do. We're just saying select all these from our tuition data set. We need to tell it, you need to put it in something. So here's where our assignment operator comes in. So right before where we have the select call, I'm going to say tuition 2. This is our second, like a more pared down version. You can name it whatever you would like. And then again, we're going to use that arrow, the assigner arrow. And I have a keyboard shortcut. It just makes it a lot easier. Now, if we run this line, nothing is going to come up below. We didn't actually ask for any output. We just said, do this function and name it this other thing. Now, if we look over, though, in our global environment, we are seeing that there is now something called tuition 2. And if we look at that, it is going from name all the way to in-state total and everything in between. So now we have the data set. Maybe this is the data set that we wanted. Maybe it's not. So that is one way to select pieces. What is very nice is that there's also a deselect option in a way. You're still using select, but we initially said we wanted to get rid of the X variable. We wanted that column gone. To do that, so I'm going to, I'm just making a new line to show these different options. So here, you can also put in comments if you want. If individual lines are helpful, you use, again, the pound or hashtag. And then this is the selecting data columns. And then I'm going to make another comment that just says deselecting or deleting. That's a better word for deselecting, but. And what we're going to do, I'm going to name a new variable called tuition3. And I'm going to have my assigner arrow. I'm going to say we're still using select, because select is a way to get columns. We want to select. We're still using tuition, but we don't want the X column. And to say I don't want something, you actually put a minus. So we're going to say minus and then X. Let's see if it'll work without the parentheses. Without the quotations. And now you can see up again, nothing should come out right below. You can see over in the right that tuition has 11 variables, tuition 3 has 10. We take a look at tuition 3, that X column is gone. And the other one, so any questions, or what questions do you have for us at this moment? I'm trying to keep an eye on the chat. It looks like things are pretty calm.
Yeah, just if you didn't have 11 variables because you didn't you started out with 10 because of when you downloaded, the minus X won't work.
Yes.
Because it doesn't exist.
It doesn't exist. So it's like I can't take this away.
And also, just as a heads up, so sometimes when you're typing in code, something that stops me is I see a little X on the line number. I don't know, Justin, if you could, yeah, right there. That's not because you're doing anything wrong. R is just like trying to like preview what you could be doing wrong sometimes. It's kind of like when, I don't know, as if you were doing like word processor and it was telling you like a word was spelled incorrectly when you hadn't finished typing it out.
Exactly. Yeah, it's here to help you. So it's like, hey, something's not right here. And oftentimes you can go and just like hover over it. I'm not even clicking on it. And just saying there's something, like you don't have an ending bracket. And if you look really close, there is a little squiggly red underneath this first one, meaning there's no accompanying closing bracket. And you can see one other cool thing I think it's cool because I'm a huge nerd, in case you haven't figured that out with my Harry Potter and like Doctor Who things in the background. You can go, if you navigate next to one of the parentheses, it shows you, it highlights the other closing side of it. So here, if I click here, there's the closing one. So that's another way to show like how things are. I'm seeing that lists are showing up below, but not in another tab. And that may be because you're only using, you might not be assigning it to something. So maybe the assignment operator is not in there, or maybe you're highlighting this and running that, and then it will show there because you're running only what is highlighted. If you instead, maybe you can run all of it over and it will be here. The other important thing to know, at least when working with data sets and trying to like manipulate them and update them, is that it operates in a linear fashion. So if let's say I'm going to, again, clear this data set. I'm clearing my environment. This would be just like restarting from brand new. That now we have all of these pieces, and let's say we just kept naming it tuition. And I run these. So we run into an error because I first asked it, read in the whole data set. This one, I asked it to only select certain things. This one, it's like it doesn't exist in tuition, so I don't know what you're asking me. And so it stopped and it didn't run this last line because that X didn't exist. So it will overwrite. If you name things the same, it just overrides it with something else, overwrites it. And I wanted to take a second and talk about piping. And this might be something, Kate, do you think this is a good time to talk about piping, or should we save that for another later point?
I think it's a good time.
Okay.
Don't be scared.
No, it's great. And it's something that it's good to introduce at the beginning so that then you can start integrating it into longer lists of things. So we have selected we've selected our data set, and I'm going to run this. So this should look similar to what you have right now. And piping is a way to make your code more, it makes it more readable, it makes it cleaner, and in my mind, when I think about it, that's how I usually think about how to run code. And it is really a way to take one section and continue that forward, where right now we have these 3 steps basically. So I'm actually going to comment out line 20. At the beginning, I'm going to put a pound. So then that won't be run when we try to run this again. It will still come up here because we didn't delete the environment, but just for these purposes. So we read in the data, and then we wanted to select only a certain part. There may be other portions where you're like, and then I want to select only cases in a certain state, or cases that have so many things, or like a certain level. And so then that would be creating like a tuition 4, and then doing more code here. Then your environment will get really cluttered. To do this more in a streamlined fashion is to use the pipe. So what I'm going to do is I will take a new code chunk down here at the bottom, and I used my keyboard shortcut to do that. It's saying that this is wrong because that's not anything. So I'm going to delete that. But to insert a new code chunk, again, up here, insert R, or use your keyboard shortcut if you set one of those up. And here I'm going to show how this works. So we're going to do tuition underscore pipe, and we're going to use our assignment operator again. And then we are going to read in our data again. So CSV data, data.csv, and then close all those parentheses. And then what we're going to want to do is we want to then say, take whatever you get from this, from reading in the data, and I want you to continue that forward. And so this is a keyboard shortcut that I have. This is what the pipe operator is. It is going to be %, which is on the number 5, and then right. So is that great? That's greater than, and then % again. That is what is the pipe operator is. There is I don't remember what the keyboard shortcut is for those things. Let's see where pipe is. Does anybody know what the pipe operator, or did they find it? There we go. I think this is the default.
Pipe operator I don't like, and I would shortcut that if you find you're using pipes a lot.
Yes. And so I have mine shortcutted, but this is what it usually is Control-Shift-M or Command-Shift-M for Mac, I believe. It's just way easier than having to type %, greater than %. And so it is, again, saying take whatever you get from this one. So this would be our whole data set. And then I want you to funnel it or pipe it into our next operator. And usually what I'll do is use an enter line, just a return line, again, to make it look a little bit nicer in the way that this is like personal preference. You can write it on the same line. It's just easier for my brain to think about these things. And then we can say select. And the one thing here is we don't have to tell it what data set to look at, because it is pulling the data set from this line here. It's saying take this, funnel it into this next sign, this next function, and do what I ask you to do. So we can actually just put -x. And in my head, this makes more sense, that you're saying read in the data and only select and take out X. Whereas this is read in the data, take the data, and then take away X. So if we run this, our tuition pipe will have the same number of variables and look the same as tuition 3. Let's see, can I delete? Yeah, that's okay. So our tuition 3 has 2,973 with 10 variables, and pipe has 10 variables as well. And you can continue on with pipes, and we'll do that here in a second. But first, I see that there is a question that you can read in different data with the concatenation of like numbers. Usually, if you are including numbers, it can get tricky. I would advise not using numbers as column names, just because oftentimes you can so I'm just going to copy in what was asked so that we can all see what this is in case you're not looking at the chat. So here on line 25, this was asked, and if we run that, what it's actually going to do is, here, I am going to go down to the console and again just type that names function. So we're going to go names tuition, and what this is actually doing now is it's taking the first column, it's taking the second column, and then it's taking the 4th through the 10th column. And we look here, so it should be taking, before I look at it, I'm going to make a guess. Let's see, it should be X and then name, and then that's number 3, so it's not going to do that one. and then it's going to do state all the way to out-of-state tuition. And if we look at this tuition 4, I think that's what I said. We'll say that's what I said. That is correct. So when you're using numbers, it will refer to column numbers. And it might be the case that you have so many columns you forgot what one is called, and it might be like XYZ126. And you're like, I know that's, for some reason, you know that's the 126th column. And you can just do that. I would usually go with using names, at least. Having alpha or like alphanumeric do numbers and letters for column names.
Yeah, I was just thinking about that. Like the reasons why you would use column numbers instead of names is there's like two parts to it, right? Like it's better to use names probably as a first go because that's more replicable. Like if someone gets a different sheet with a different column order. But then again, I'm thinking about if you have a massive amount of repeated data, like day 1, day 2, day 3, day 4, it might be easier to do. I guess you might already know this. I just thinking out loud in case this is helpful to anyone else.
Yeah. No, and that is, let's see if there are, I'm again looking at the names of the tuition data set that we have. And one thing that's also might be the case is you have a large data set and you want, maybe it's of a particular measure. So you have like item level data of the Beck depression inventory. And so there are 23 or 20, I can't remember, 20 something items, and they might be BDI 1 to BDI 20 something. But then there's also all these other variables, and I just want all the BDI variables, and I don't want to have to like figure out where they are. So we're going to add on to this pipe function here. So again, we're saying read in the data, put that in. I only want to, and take out that X variable. And now I added another pipe going down again, and I'm going to say select. One of the cool things that you can do here is within the select function, say contains, open parenthesis, and what I was looking here is it looks like the word state is in a few of these. So what I'm going to do is in the contains parentheses is do quote state, end quote. And if we run that, you'll see then our tuition pipe goes down in the amount of variables that you have. If we view that, then I'm just clicking on tuition underscore pipe. You see that all of our columns have the word state in it. And that can be very nice and easy to then like select and make a data set more manageable for you to look at. Now what we're going to do is again combine this. Let's do a filter. So maybe we only want, let's see, what are some of the tuition? Let's say we only want like the state of, I was in Colorado for some time, so I'm going to say Colorado. So we only want state to be Colorado. And what we can do is, again, we can keep adding pipes on here. So now it's going to take this again, and we are going to filter. If we look back again to, I'm going back to this is our cheat sheet for Dpplier. And you can see that we are now in manipulating cases, and we want to filter. And so this is extracting based on some criteria, some logical criteria. And the way that we do that is we're saying what data set we want to use, which here's an example. So the iris data set, and then what is the logic that we want to apply to it. And if we go back to now I'm in our workspace here. Now I'm adding this filter command. We again don't need to specify what data we're using because we've been using it. And we just need to know, let's see, we want the state this variable. I'm again looking down in the console to see what our names are. And we want the state to equal. And here you have to use, because you want to, when coding, you have to use a double equal sign, because sometimes you can use the equal sign as a assignment operator. And so whenever you see this like arrow, there are individuals who will use an equal sign instead, just one equal sign. So in order to say that these two are equal, or you're doing some logic to it, you have to use two equal signs. So state equals equals, and then quote, and it's capital CO for Colorado. And then we run that. We can see that that was incorrect. I was looking at the wrong one. It is actually the state code. So now, if you did this and you saved it, so look, I'm going to save it. If you did this in SPSS, your data set would have 0 observations in it, and you would be upset. You'd be upset, to say the least. Because we're using R, we can actually go back, we can reload the data, and I'm just looking back down here, we can actually just go here and highlight up until that last line that we ran. So I'm just highlighting before the pipe operator of that last one, hitting Control Enter. So it only runs what I highlighted, and you can see everything is back. And the reason that things weren't going the way that I wanted was, if we look at tuition pipe, I was asking it to filter based on the state column when I should have been using state underscore code. So if we go back here and instead say filter open parentheses state underscore code and run that again, now you can see that tuition underscore pipe has only Colorado colleges in Colorado. And that is one way to organize your data sets in getting all of these pieces together. One thing that I like to do is you save frequently, just like you normally would, but to highlight and push for that reproducible workflow, and making sure that, say your computer crashes or you're working at home, so someone comes in and like spills something on your laptop and everything gets fried. So like restarting R frequently, I've cleared everything's gone now basically, and all I need to do, I can say run, and you can run all of the chunks. Run all. This will run all of them, and now I am right back where we started, right back where we ended. And here is my tuition pipe, and we are all set to continue with everything. To highlight I know that these were only just a couple lines, and I often use the pipe even if I'm just using 2 lines. It just helps get in the habit. This is what it would look like if you didn't use the pipe. So we will have to do this one. I'm going to put tuition. You don't have to copy this. This is more just to show how much this saves, how much time this saves, and just like how readable they are. So we would then have to say tuition. We would just be overwriting what we just did, and then have select. And maybe we would want, because we don't want to mess things up, we would have to take this and then not that. And then again, we would say tuition, no pipe. We don't want to mess things up, so we would say another data set, selecting from this data set. We only want the ones that contain the state variables. So it would have to look like that. And then we would do, maybe we would say tuition final, because we're like, this is the final one, I promise. Maybe spell things correctly. And then we would say filter. We'd have to filter based on this one. And then we want to have state code. And if I run all of these, our tuition final here and tuition pipe. So we have tuition final here, tuition pipe here. They're identical. One, to me, looks a lot easier to understand and walk through than this other one. And it's a lot cleaner. It's just a little bit more straightforward. So I would advise, as you move forward, to try to implement using the pipe as much as you can. And it's usually is most helpful in this first portion in using select and filter and anything here in the tidyverse or in Dpplier will use this functionality. And you can see up here in the top left, this is the pipe. So we have all of these components up here that you're able to use and really make a lot of use of. One of the other ways that you can do this, so here I will have this like pipe section. I'm just creating a copy of it, still in the same chunk. Sometimes I will have it just load in a data set like this. So here on line 38, just have that separate. And then here to start it, you can just say tuition underscore pipe and then start the pipe from there. So it's even a little bit cleaner, but that's just all kind of up to you and what your preferences are and what that looks like. So that was a lot of just getting R to look how we want and to do some basic, very straightforward data manipulation, organizing a data set. And I probably spent more time talking about these pipes than we needed to, but I think it's really helpful, and it builds that foundation so that as you get more complex, it's easier to add those pieces on than trying to relearn and restructure what you're doing. One of the, I know we're towards the end of what we said we were going to have for today's session, and we appreciate all who have stuck around and hung out with us. It's more than hanging out. We're doing some cool stuff. One thing that I wanted to just highlight is we can, in psychology, we use we'll have basic descriptive statistics right in the beginning of papers, or usually you just take a look at your descriptive statistics. And so this is means or standard deviations, and sometimes in SPSS or other programs, there are simple things to do just that. And one package that is really helpful, at least within psychology and maybe in your field, is called Psych. So we are going to go down here into the console and do install.packages, and then use quotes, either single or double, and then say Psych, all lowercase. And again, I had recently updated all of these pieces, so it's there. And then again, this is a new library, so we need to up again at the beginning of our code. We're going to say library psych. And just because you typed it, that doesn't mean that it went and got your book off the shelf to read. You need to run the library line. You can either run everything again with this play button, or just on that line, put your cursor in there and do Control Enter, and you'll see that library psych is run in our console down here. And I'm scrolling down to the bottom. I am going to insert another code chunk here. And we have our tuition pipe data set, which is one that might be useful for us. let's see. So what we can do now is actually say describe. If we type describe, and then we need to say what data set we want it to describe. And I'm going to use the tuition_pipe. And if you hit Control Enter on that, it will give you descriptive statistics for your variables. This will give you mean, standard deviation, skewness, and kurtosis. And this is another reason why I tend to like it output in the console, because this, you're often missing some of the pieces of information. So I will go into the gear up at the top, do chunk output in console. I'm going to remove that and then run that line again. And so we're just looking down here in the console, and you're seeing each of the variables that we have. So the average in-state tuition for Colorado schools is $13,419, which seems very low.
I just need to jump in and say this is awesome, because I actually didn't know describe exists. I would just do mean and SD, and well, I never did anything with kurtosis, but like that's great, or skew.
Yeah, this is wonderful, and you might notice that the means and standard deviations for our state and state code variables are 1, and they like don't make sense. If you look back at our data set, it's because those are it's the state name and the code, so that we can't get anything on those. But you're able to get that. And then one of the other things that, as we're wrapping up, which I think is really great, is a package called Sjplot, and one that I love to use. So here I'm just Googling Sjplot, and I will put this in the chat here. So this is, someone created this, and it's now you're able to get it through the CRAN, which is what we've been doing with this install.packages. This is there's different levels of investment in how websites look to describe what packages do. I really like this one. So some of the things that Sjplot does a nice job of is creating working with tables, creating regression tables, and creating like correlation tables and pieces like that. So I go into the references section here, and these are all of the different plots or tables that you can use. So here, what I'm going to do, we have a tab_core. I'm going to put this off to the side here so that we can have both pieces up here at the same time. I'm just moving windows around so we can get a better look at everything. This, again, if you have not used Sjplot in the past, you're going to need to do install.packages, single or double quote. SJ are lowercase, the P in plot is uppercase, and then LOT. And see, I am just real bad at learning how to spell packages. So we get that installed. And again, we have a new library that we need to go back up to the beginning and say library Sjplot. And it may take a second. So there we go. Now we have Sjplot here, and I'm going to go down. I'm going to create, still in our description, right underneath where I have describe, I am going to take this tab_core. So tab_core, and you can see as I start typing it, it's like, hey, I think you mean this. I'm like, yes, I do mean that, RStudio. Thank you so much. And we are going to use the tuition_pipe data set. And let's run that and see what it gives us. This was what I was expecting, because it's saying that X must be numeric. And that, like, you can't run a correlation with this data frame that we have, because how do you correlate the word Colorado with tuition? Like, it doesn't make any sense. So one thing that we can do, which is really cool, is we can take our, I'm again just like starting with tuition pipe, and then we can pipe it, and we can we can select, then again, now I'm going down to the console and asking for the names of the space of the data set. So tuition underscore pipe. And we don't want state or state code. So instead of saying minus those, I'm just going to say select from in-state tuition. So in-state underscore tuition colon out underscore of state total. And then I'm pretty sure that Sjplot works with pipes. We can actually just pipe all of that information into tab underscore core. And when we run that, let's see, now it's saying that there is an error with NA deletion. It looks like it needs to say something. So if we look back, I'm pulling up this information here. It forces you to say what kind of missing, like, NA deletion do you want to use? Do you want to say it's listwise or pairwise? This would be another, like, we could go into more detail here about what all that means, and I will spare you from my statistical ranting. But you have to just specify what kind of missing data deletion you want. I'm going to say pairwise. This is just an option. So in SPSS or some other program, that would be like a checkbox that you either check or uncheck. And then let's see what happens when we run that. Now it's asking, because if we look back at the documentation, that this core.method is also an option. So this concatenation, it's like you need to have one of these three things. There's either Pearson, Spearman, or Kendall correlations. So then we need to say comma, core.method equals, and usually Pearson is one that's most often used in psychology. So I will run that. And the reason why it looks so wonky is probably because of the piping that we did, and it's removing all of those Colorados. But if you look, if you ignore the bold, which we can definitely clean this up. I think it repeats it over and over. Yeah. That's just an issue with the piping, and I did that quickly so that I could just we could show what this is all doing. We can clean this up and make it, this is like a correlation table that you might often see in a paper. You can put the different names, but you can have a different title and set all these pieces up where now we're seeing that in-state tuition, in-state total are highly correlated at 0.95, and that is, it even includes the significant levels. So this is something then in our viewer, it shows us our correlation matrix. And this is then something that would be easy to then put right into a paper.
And this is APA format, like for tables?
It should be, yeah.
I mean, obviously not this in its present form.
Yes, just take a screenshot of this and say, here you go. That's my whole paper.
This is great. I've been using Cable to like get my stuff in, but it's not APA format. So this looks much more official.
I like Sjplot a lot. Cable is like a basic table one. There's tons of different packages that can be used for a lot of these things. And at a certain point, it becomes your preference in what you would like to see. And I've preferred to use Sjplot. I've heard I used to use like Stargazer or Cable or There was one called APA tables that is not really being updated. But there's a lot out there. And I think that's another thing that can be overwhelming with using R and RStudio, because you want to know which is the correct one to use. And really, it's like there aren't really, it should all be okay, as long as you're getting what you want and how it looks. But again, what I can do is I'll save this. I can restart R, and then, like, let's say I get rid of all this stuff. I can run everything again, or I can even take this data set, I can take this folder, and I can, and yeah, it's sometimes with the piping, it like just gets a little wonky. But I can send this folder to anybody, and as long as they have RStudio installed and R installed, they'll be able to get these same results. And I think that is...
We just have a quick question.
Yeah.
Before. So Hannah's having trouble finding the function tab. It says tab _ core error. I'm wondering if that's a library or a package problem.
I would suggest trying to make sure that you have this library Sjplot and run that so that you see it down here in the console. So if I hit Control Enter...
Sorry.
What?
I was saying the wrong library.
Oh, no. Oh, there you go. So yeah, then it would be install.packages Sjplot. Usually if you get something that says, I can't find this function, then it's because either the library or package wasn't installed, or you didn't call it into your workspace. So I think, Kate, do you have anything else for today's session before we stop the recording, and then we can stick around and see if others have questions or plans for us for tomorrow?
No questions or things I want. The one thing, we do have a question.
Yeah, go right ahead.
Well, I'll just wait for it to be typed out. But in the meantime, just so you guys have an idea of what we'll do tomorrow, we'll probably do ggplot. So that'll be our data visualization. So, okay. So the question is, why does it ask to install RTools?
RTools is, it's another package that is often used in a lot of other like user developed packages. If that is a problem for some, if getting RTools installed is difficult, then we can, try installing RTools. You should just be able to do the install.packages RTools. And then once you have that, like, again, these are all free, so you won't ever have to pay for any of these things, which is super great. Some of them there's dependencies of other packages, and sometimes they'll install them, sometimes they don't, and you have to just force R to do things.
Beh, devi installare questo RTools. No, a me mi dice di installarlo.
Sorry? Okay.
Sorry.
So, oh,
I just unmuted me to ask the question, but then I wrote it, so I'm sorry I left it off.
No, that's okay.
You're all right.
Yeah.
So the YouTube video won't be up until probably next week, we'll say.
I'm going to try to get it, like, it's not going to be edited or anything. It's going to be exactly what was recorded right now. So this conversation will be on the at the end of this video, but I'll be trying to upload those later today. And so you should be getting those. We'll try to, the links to things might not be up as quickly, but we'll get those up. So like Kate was saying, we'll do ggplot next session tomorrow. And we really appreciate everyone who is watching now later or who joined us live. We'll stick around for just a few minutes if anybody else has any other questions. If not, feel free to reach out to us. Or if you're watching this in the future, feel free to tweet at us or let us know how we did.
Oh, sorry, Dustin.
That was it.
So if there was something else you wanted us to kind of, Ggplot won't take the whole time. So we were thinking we do some kind of, like correlations, things like basic data analysis things as well. If there's something you want us to cover in particular, we could do that. Just send us a message or like stick around, put it in the chat. We've also kind of been toying with doing like an R office hours in the future. So if you're someone who's like, you're starting to work with a data set and you're running into things. So if that's something you'd be interested in and would want to do, okay. So we have one taker. That's something we can kind of talk about doing in the future. We were really interested in doing it before, but we didn't have a lot of people who were yet doing R that we'd connected with. So
yeah. But yeah, follow us on Twitter, can_grad. Check out our podcast. We'll be continuing that. Thank you.